This video is going to introduce you to the idea of trig identities. The first important thing here is to define an identity. An identity is a special type of equation that is true for all values of x, or with trig, all values of theta. So, an example of an identity at its most basic is something like x equals x. That is obviously true for all values of x. Another identity is 3x equals x plus x plus x. Since 3x is actually defined as x plus x plus x, that's obviously going to be true in any case. Similarly, something like x times x equals x squared. True for all values of x. Any number I plug in for x, let's just try one, 2. Is 2 times 2 the same as 2 squared? Well, yes, that side's 4, this side's 4, great. And it would work for any value I plug in. Some non-examples of identities are our traditional equations that we need to solve. So something like x plus 3 equals 10. Sure, that's true for one value of x, when x equals 7. But what if x equaled 2? Is 2 plus 3 equal to 10? No, of course not. So since it's not true for all values of x, it's not an identity. Another example, 2x equals 20. Well, that's true when x equals 10, but no other time. Even some trig equations are non-examples. If I said the sine of x equals 1, well, that's true when x equals pi over 2. It's also true when x equals 5 pi over 2. And anytime I add 2 pi to any of these, so there's many answers, but unfortunately not all values of x work, so it's also not an identity. Now this picture may be a little overwhelming at first, but if we just focus in on a few, these are going to be some identities that you've already seen or already know. So just looking up at the top right, we see that tangent equals sine over cosine. That's something that we know to be true. Any value of x I plug in would be true here. Similarly, since cotangent's the reciprocal, I know that cotangent's cosine over sine. True for any x. The next three we see are our reciprocal identities, that cosecant is 1 over sine, secant's 1 over cosine, and cotangent is 1 over tangent. And then we have our three Pythagorean identities, which are really all derived from this first one, that sine squared plus cosine squared equals 1. All of these are identities you'll probably use when you prove more complicated identities. Here are some words you're going to see when you're asked to prove or verify an identity. Words like prove, show, transform, verify, those are going to have to do with identity questions. Usually with an identity question, you're actually given the answer and you just need to show the work involved to get to the answer. Words you won't see with identity questions are things like solve. Let's look through an example of an identity problem. This one's pretty straightforward. So we're asked to verify this identity that you see up at the top. Cosecant of x times the tangent of x equals the secant of x. Now this is something that we don't already know to be true, but we're asked to show that it is true. So my first tip when you're trying to do this is to work with only one side. And we're probably going to pick the more complicated side. So I'm going to choose the left-hand side, cosecant of x times the tangent of x. If you just glance over my work really quickly, you'll notice I never touch that right-hand side. Every single step still says secant of x on the right. I'm only looking at the left. All right, so first step, I just recopied the problem. Nothing very exciting there. In the second step, I changed the cosecant of x into 1 over sine and the tangent of x into sine over cosine. This is my second tip. Try to write everything in terms of sine and cosine. It's probably going to help you. So now I have two fractions that are multiplied together, so I'm probably going to multiply those two fractions. So multiply the numerators, 1 times the sine of x, that's just the sine of x. Multiply the denominators, sine of x times the cosine of x, that's sine x times cosine x. But then notice here, I have a sine in the numerator and a sine in the denominator, so I can cancel those out. which leaves me with 1 in the numerator and cosine in the denominator. So 1 showed up here, and then I still have my cosine. Travel down. Well, 1 over cosine, I know that to be the secant of x. So what I'm really doing is I'm just going step by step on the left-hand side, and I'm always just writing out the same thing on the right. And then I know I'm done when I have what I call an obviously true statement. Well, obviously the secant of x equals the secant of x. So since we used logical algebraic steps to transform the left-hand side into the right-hand side, I know that this identity is true. Let's look at a slightly more complicated example that involves the Pythagorean identity. This time we're asked to prove that the secant of x minus the tangent of x times the sine of x equals the cosine of x. Again, not something that we would know before, but it actually turns out to be true. So let's see how we can show that. Again, first line is just rewriting the problem. Second line is I have changed my secant and my tangent into 1 over the cosine, so secant became that, and tangent became sine over the cosine. I didn't mention this, but I've decided to work with my left-hand side and see if I can transform that into the right-hand side. So notice everything along the right-hand column is always just that same cosine of x. Okay, so first I change into sine plus cosine. Again, that's not always going to be the best step, but usually it is. And now I notice that I have the subtraction of 2 fractions that have the same denominator of cosine of x. So that's going to be the denominator of my new fraction. And then my numerator is 1 minus, well, I had sine x times sine x, so 1 minus sine squared x, all over cosine. Okay, now the next tip I have is that whenever you see a square, like a sine squared, a cosine squared, something like that, you're probably going to use a Pythagorean identity. Now we know that the sine squared plus the cosine squared equals 1. Well, I don't have sine squared plus cosine squared here. What I have is 1 minus sine squared. So what if I subtract sine squared from both sides of this identity? Now I have that the cosine squared equals 1 minus the sine squared. Well, look, that was what I had right here, 1 minus the sine squared. So I can just replace that with the cosine squared of x. Again, I kept my denominator the same. Well, cosine squared over cosine just cancels out to cosine. So looks like I'm left with the cosine of x equals the cosine of x. So I'm good. So here's a quick list of my tips. I'll give you a worksheet with these in class. But transform only one side into the other side. Keep going until you have an obviously true statement, like x equals x, or secant equals secant, or sine equals sine. Replace reciprocals with sine or cosine. So if you have cosecant, replace that with 1 over the sine. Replace tangent and cotangent with sine and cosine, so they're appropriate fractions. Look for your Pythagorean identities. And then we didn't see this in the video, but the last trick is going to be to make common denominators so that you can add or subtract.